This is recording for Edexcel Further Pure 1. Further Vector Geometry, Section 2.1, the equation of a line r minus a cross b equals 0. Well, we know that if two vectors are parallel, then the vector product, which is a cross b, is equal to mod a mod b sine theta n hat, where n hat is a vector normal to a and b of unit size. Now, if sine theta is equal to 0, then and a and b are not 0, this means that a and b must be parallel. Sine theta equal to 0 implies that theta is equal to 0 degrees. So let's look at the line which is in red here, and let's say that its direction vector is given by a vector b. Well, that must be parallel to the vector from a to p. And the vector from a to p, if we look at the diagram, AP is equal to vector r minus vector a. And therefore, AP cross b equal to 0 means that we have r minus a cross b is equal to 0. And this gives us an alternative way of writing the equation of a line. Note that this is a 0 vector here, so when I've written it, I've underlined it, although in print you'll see it as a bold 0 rather than a normal case. Well, in the next few slides I'm going to look at some of the other ways of writing equations and how we can then convert them into this new form. So this is the first one, where we've got the direction vector here and a point on the line. So we can see that the direction vector 3, negative 1, 2, and we have a point 1, 3, negative 4. Now that's what we need to have our r minus a cross b equal to 0, means that r minus the vector which is the point 1, 3, negative 4, and then we need to take the cross product of that with the direction vector which is 3, negative 1, 2, and that will be equal to 0. So very, very straightforward in that case. In effect, this form of the equation has given us the a and the direction vector b. Another way of writing the equation of the line is in its Cartesian form. But remember, from the Cartesian form, then we can write down a point on the line. So the point on the line is given by 1, 0, negative 3. So the 1, negative of these values, negative and negative 1 is plus 1. Here we've got 0 and then negative 3. So this is the point on the line. And the direction vector is given by the numbers in the denominator, so that the vector b will be equal to 4, negative 2, 3. And therefore, we can change from the Cartesian form into our new form by simply doing r minus the vector for the point 1, 0, negative 3 cross product with the direction vector 4, negative 2, 3, and that must be equal to 0 vector. So there are several ways of writing the equation of a line in 3D. The form of point plus lambda times direction, this is what we call the parametric form. The one that we've just looked at, which is vector product form, the Cartesian form, and then there's one other which uses something called the direction cosines, and that we will look at in the next video. So direction cosines. So that is the end of this video, and say in the next one we'll look at the idea of the direction cosines of a line.